Hello, this is day 2 of the unit circle. So we are putting together things. We've done the Pythagorean theorem, special right triangles. We put them on a coordinate plane. And so today we're going to evaluate different expressions. So we've done 3 circles with 3 different reference angles. And we've discussed them. And we're going to use these diagrams to help us be able to evaluate certain trigonometric expressions. So here, reference angle of 30. This one's reference angle of 45. And then reference angle of 60. So when you put all of these together, it makes most of the unit circle. There's just one other thing that we need to do, and we'll do that later in the lesson today. So we're going to take those circles with the triangles, coordinate planes with the special right triangles, and use them to evaluate a trigonometric expression. So a trig expression is just, you have a trig function, sine, cosine, tangent, cosecant, secant, cotangent, and you're evaluating it at a particular angle. Now we've done all 6 of them for a particular angle. This time we're just finding one. And I don't memorize them, so I use diagrams. So I redraw the diagrams every time. And you get quicker as you do it, but you can also use your pieces of paper and they will help you draw the diagrams. So the first thing you're going to do, you're going to draw a coordinate plane. You're going to decide where is that angle going to land? Where's the terminal side, the ending side? What quadrant will it fall in? So I know 120 is between 90 and 180. So we're going here. So what is that reference angle? Remember, the reference angle is the angle that's created by the end side and the x-axis. So I know this is 180, so 180 minus 120, this is 60. So you're going to look at your 60 piece of paper, and we're going to create a triangle in the second quadrant. So this is what you should have in your paper. This is your short leg, and if you don't want to look at your paper, that's fine, because I never do. I just redraw them every time. I know the short leg's here. I also know it's negative. Don't forget that. And the long leg then is the square root of 3 over 2. Once you have that, you look and say, okay, what is sine? Sine is opposite over hypotenuse. So if I'm looking here, my angle, using just the reference angle, my opposite's here, my hypotenuse is there. So I have the square root of 3 over 2 over 1, which of course, anything over 1 is just going to be the numerator itself. 5 divided by 1 is just 5. 2 divided by 1 is just 2. 0.5 divided by 1, 0.5. And then that's it. So you're only doing sine. So the sine of 120 degrees is root 3 over 2. So now we're going to do this next one. Now it's in radians, so you can do a couple things. Some people may know where this falls. You can look at your paper, or you can convert it to degrees. So it's up to you. So if you convert it to degrees, it's negative 150. Now, if you didn't know that, or didn't want to convert it, we know a couple things. I know that it's 6 in the denominator, so the reference angle immediately is 30. I also know that 5 is less than 6. So when I'm coming around this way, this is going to be negative pi, which is the same, 1 pi, which is the same as 6 pi over 6, right? 6 over 6 is 1. And 5 is less than the numerator 6, so it has to be here. So that falls in the third quadrant. So this is 1. The opposite then is of the 30 degree short leg is negative 1/2. And then this is the long leg. Once you have that, we're going to go back and say tangent. Tangent is opposite over adjacent, which is Opposite is negative a half over negative root 3 over 2. Negative is going to make it positive. And I both have 2's in the denominator. So if I multiply it by 2, top and bottom, then that's going to simplify out. So what do I have left over? The square root, 1 over the square root of 3. We do not like square roots in the denominator. So we're going to simplify by multiplying square root of 3 by the top and bottom. And it is root 3 over 3. So we're just going to practice and practice and practice. All right. Draw coordinate plane. Decide what quadrant is it going to fall into. Now, I know the reference angle immediately. Right? If it's 4 on the bottom, that's right, it's 45. So this is going to fall, do you know? So we're going positive, we're going this direction. This is pi, this is 3 pi over 2, and it actually is here. If you changed it to degrees, you would find that was 315 degrees. All right, so that's 45. 1. So we know the numbers that go with that. The sides are going to be root 2 over 2 and root 2 over 2. Don't forget, it is negative. Secant. Okay, secant is hypotenuse over adjacent. Adjacent is always going to be the side that, if you write it in this way, standard form, that it's always going to be the leg that's along the x-axis. So the hypotenuse is 1, and then the adjacent is root 2 over 2. I'm going to make that. So I don't want that 2 in this denominator. So this becomes 2 over root 2. But we don't like root 2's in the denominator, so we're going to multiply by root 2. And some of you may have seen the pattern. This is 2. So this will simplify out, right? 2 over 2 is 1, leaving just a nice square root of 2. All right, cosecant of negative 30. What quadrant is that? Okay, that's right. So we're going this way, so 30 is here. So 1, our short leg is here opposite. It's going to be negative half. Our long leg is long on the x-axis, root 3 over 2. Cosecant is hypotenuse over opposite. So hypotenuse is 1. Opposite is negative half. I'm going to multiply 2 to the numerator and denominator. That's going to be 2 over negative 1, which just simplifies to negative 2. Yep, wait, there's more. We're going to keep doing them because you'll recognize some numbers. You'll get to start to see some patterns. All right. Quadrant. All right, what quadrant does this fall in? It's negative. Now, what's my reference angle? 60, right? 3 is in the denominator. So it's going negative. If we hit 6 pi over 3, it's 2 pi. So it's almost all the way around. So it's in this quadrant. So if you changed it to degrees, you would have found that is 300 negative. Okay. All right, so this is 1, root 3 over 2. This is half. Now, some of you may have learned this already, so you may have your own methods, and that's great. So cotangent A over O. So opposite, adjacent. So we have half over root 3 over 2. Again, similar, right? 2's undo. Square root of 1 over the square root of 3, which simplifies to root 3 over 3. Okay. All right, what quadrant is this in? 315 positive. It's all the way around. My reference angle is 45 because you're subtracting it from 360. It's going to be 45. So 1 root 2 over 2 negative root 2 over 2. Cosine is ka, so ka toa. So it is root 2 over 2 over 1. I'm not going to put the 1. And there you are. So these are using triangles that you can draw the triangles in the different quadrants. But what if you can't? What if you can't draw a triangle? So if we're looking here, what if I gave you had to find sine of 90? Okay, you're like, okay, that's here, Miss Mendoza, straight up and down. How do I draw a triangle? You can't. So when it falls on the axes, any of the axes, the axis plural. Okay. So anytime you have 0, 90, 180, 270, 360 is the same as 0. Or going backwards, remember 270 is the same as negative 90, or negative 180, or negative 270, negative 360. It's special. And we're going to actually use the points here. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay. So I have a table. And this should look familiar. You should have a table. Here's the last sheet of paper for the handout that you should have printed out. So go get that. And we're going to fill this in. So the first two columns, this is in degrees, and then this is in radians. And 0 and 360 are the same. And also, I didn't put the negatives, but if you can look at the circle, 270 is the same as negative 90, so please make note of that. So what happens is this, when it's on it, it's the sign of 0 is actually 0. The cosine of 0 is 1. And you're like, oh, Mr. Doza, how did you know? Show you, see if you can find the pattern. At 90, the sine is 1 up here. And then the cosine is 0. Over here, the sine is 0. Can you guess what the cosine is? Negative 1. Okay, for 270, which is down here, this point, sine is negative 1, and cosine is 0. Okay, so what happened? The pattern, this turns out to be the y coordinate of the point, and then the cosine turned out to be the x coordinate of the point. So they're related to the point. The tangent, this one is 0. Turns out to be y over x. So 0 divided by 1 is 0. So over here, if I have 1 divided by 0, can I divide by 0? No, you can't. Changing the color. This is called 1 divided by 0 is called undefined. Okay, I'm just going to be U and D. U and D will equal undefined because I can't fit it in the little rectangle. So remember, anytime you divide by 0, not possible. Okay, change the color. So I have 0 divided by negative 1, that's going to be 0. And then negative 1 divided by 0, again, that is undefined. Okay. So then cosecant is the reciprocal, right? So it's going to be 1 over y, right? We're flipping that over. So it's going to be 1 over y. Okay. Ignore that. So when you have 1 over 0, that's right, it's going to be undefined again. So guess what happens to this next one? It's going to be 1, right? So secant is a reciprocal of cosine, so it's going to be 1 over x. So 1 over 1 is 1. Nice. And then this one, again, it's going to be the reciprocal of 0, which is undefined. Okay. All right, so the reciprocal, again, so we're doing cosecant. The reciprocal of 1 is 1. The reciprocal of 0 is undefined. And the reciprocal of undefined, so you're really doing the reciprocal of 0 over 1. So if we wrote that. So you're doing 0 over 0. That's not what I wanted. Well, actually, 0 divided by 0 is a really interesting conversation. I'll wait till a different day. All right, so this 0 divided by 1 is 0. All right, so let's go here. So doing this, reciprocal of 1 over 0 is undefined. This is going to turn out to be negative 1. Do we sense a pattern yet? Okay. Reciprocal of negative 1 is negative 1. Reciprocal of 0 is undefined. And reciprocal of undefined is 0. Oops, wrong color. So these angles are the ones that students often forget, and then they get really confused because you can't draw the triangle. So remember, these are special and they come from the point. So make sure that you have this. Okay. And let's see, this would be x over y, just the reciprocal of this. So we're going to do the special ones, show you how they work. Okay, so I'm still going to draw a coordinate plane because I'm not sure where this falls. This just helps me give me a visual understanding. So negative pi over 2. So pi over 2 is 90. Remember, the pi is 180. So 180 divided by 2. It's negative 90, which is here. So what's that point? That is 0, negative 1. So now you're just going to say, Ms. Mendoza, I don't have it on the piece of paper. Remember that it's also 270. So this is y over x. So y over x is negative 1 over 0, which we know we can't have. So this is going to be undefined. All right, cosecant of 270. That's here, we just talked about it. So we have 270 here, still 0, negative 1. Okay, so remember that this is the reciprocal of sine. So sine is negative 1, so the y value. The reciprocal of negative 1 is negative 1. Sine of pi. Sine of pi is here. This is negative 1, 0. That's pi. 180. Sine is the x value, so it's going to be 0. Okay, there you are. So again, if it falls on any of the axes, X or Y, so here or here, special angle. Use the point. All right, here are problems on your own. Really know what's going on. Draw a picture. Figure out what quadrant it's in. Draw a right triangle if possible. If not, know which point it is related to. Right? And don't forget to answer the EQ. Thanks for watching. Bye.